Let's move from the natural sciences to logic and mathematics. In logic and mathematics, we find that a 63-year period from 1874 to 1937 exhibits a similar sort of discipline transforming set of discoveries that we saw in the natural sciences. 1874 finds Georg Cantor publishing on a property of the collection of all real algebraic numbers, in which he uses naive set theory to demonstrate that the real numbers are more numerous than the natural numbers. Cantor's theory of transfinite numbers, establishing that there are infinite sets of different sizes, proves so powerfully counterintuitive that even such geniuses as Henry Poincaré and Hermann Weyl initially greeted it with disbelief. Gottlieb Frege publishes Begriffsschrift in 1879. In this work, Frege adopts Cantor's naive set theory and presents the first rigorous axiomatized first and second ordered predicate logic, including functions. Frege takes as his ultimate goal the derivation of mathematics from logic, thereby reducing the former to the latter, a project called logicism. Logicism represents one approach to the overarching project of providing an axiomatic treatment of all mathematics on the model of Euclid's elements. More precisely, the project then underway seeks to axiomatize basic arithmetic on the natural numbers. In 1899, David Hilbert publishes his Foundations of Geometry, in which he offers an axiomatization of the geometry of Euclidean solids, that is, a three-dimensional Euclidean geometry. An American graduate student, Robert Lee Moore, develops and publishes an alternative axiomatization in 1907 as well. Bertrand Russell and Alfred North Whitehead published Principia Mathematica in 3 volumes, 1910, 1912, and 1913. Principia attempts to axiomatize mathematics, arithmetic on the natural numbers, in the logicist tradition. The development of second-order logic and the progress towards axiomatizing mathematics creates a sense that logic in mathematics is on the verge of completion. This sense continues until Kurt Gödel publishes on the formally undecidable propositions of Principia Mathematica and related systems in 1931, in which he demonstrates that any axiomatic inference system capable of expressing the truths of arithmetic on the natural numbers must be either inconsistent or incomplete. Hilbert, an axiomatization enthusiast, famously suggests that mathematics can save much of the benefits of axiomatization if one can demonstrate a general technique to identify unsolvable problems, the elements rendering any axiomatization incomplete. However, an unsolvable problem of elementary number theory, published by Alonzo Church in 1936, and then On Computable Numbers with an Application to the Einzigen Problem by Alan Turing in 1937, demonstrate the impossibility of this last hope for the axiomatization project. Indeed, these final 3 papers by Gödel, Church, and Turing not only serve to delimit and define the nature of mathematics, they also serve to delimit and define the nature of computability. Specifically, they lay the foundation for theoretical computability theory and the basis for modern computing devices. Let's complete this second act of the lecture by looking at a timeline that combines elements of psychology with the natural sciences and math timelines that we've just completed. 1874 finds Georg Cantor introducing his naive set theory and applying it to number theory. 1877 has Boltzmann introducing a statistical treatment of thermodynamics. 1879, Frege publishes his work beginning the logicist tradition of trying to axiomatize basic mathematics. 1885, Hermann Ebbinghaus publishes On Memory in German. 1897, J.J. Thomson discovers the electron. 1901, Max Planck publishes Planck's law. 1904, Pavlov reports the reflex arc research in his Nobel Prize speech. 1905, Einstein's miracle year, in which he publishes 4 major papers in physics. 1908, Minkowski publishes Time and Space. 1910, Bertrand Russell and Alfred North Whitehead published Volume 1 of Principia Mathematica. 1911, Ernest Rutherford publishes his model of atomic structure. That same year, Edward Thorndike publishes Animal Intelligence. 1913, Niels Bohr publishes On the Constitution of Atoms and Molecules, Parts 1, 2, and 3. That same year, John Watson publishes his first major article. 1916, Albert Einstein publishes The Foundation of General Relativity. 1919, Arthur Eddington's solar eclipse observations verify Einstein's theory of general relativity. 1922, Tolman publishes A New Formula for Behaviorism. 1925, Wolfgang Pauli publishes his Pauli equation. 1926, Erwin Schrödinger publishes his Schrödinger's equation. 1927, Heisenberg publishes the uncertainty principle and Bridgman publishes operationalism. 1931, Kurt Gödel publishes his incompleteness theorem. 1932, Tolman publishes Purposive Behavior in Animals and Men. 1936, Church publishes his undecidability paper. 1937, Turing publishes his undecidability paper. 1938, Skinner publishes Behavior of Organisms. In 1943, Hull publishes Principles of Behavior. As you can see, there was an explosion of scientific discovery across a wide variety of fields. In the next lecture module, we're going to see how the explosion in mathematics, logic, and the physical sciences helped to shape and drive the rise of logical empiricism.